The directed line segment, whose initial point is the origin, is often the most convenient representation of a set of equivalent directed line segments. This representation of the vector is in standard position. A vector whose initial point is at the origin can be uniquely represented by the coordinates of its terminal point. In this example, that would be the point 5, 5. The component form of the vector is written as displayed. The component form is based on the standard position of any given vector. Vector notation gives us the direction of the vector. From that, we're able to determine what the magnitude of the vector is. And the magnitude of the vector is written in the double vertical bars that you see. So what I have written down is the magnitude of vector v is equal to the square root of 5 squared plus 5 squared. So it'll equal the square root of 50. This then should be further simplified. We can pull the 25 out of there, and the square root of 25 is 5, and we're left with the square root of 2. One last point I want you guys to consider as you're learning about vectors here. Consider the vector that's pictured. I have the vector 1/2 square root of 3 over 2. One of the things that you may think about is, and we'll call this vector v. I want to consider what is the magnitude of vector v. So I'm going to have the square root of 1/2 squared plus the square root of 3/2 squared. And if I simplify that, I'm going to have the square root of 1/4 plus 3/4, which is equal to the square root of 1, or 1. Anytime I have a magnitude of a vector that is equal to 1, we're going to refer to that as a unit vector. Some of you may have recognized that the components of this particular vector that I have pictured is actually a vector that could be placed inside of our unit circle. Hence the name unit vector. Well, that's all I have for you for right now. Please tune in to the next presentation, which is entitled Vector Operations, and have yourself a great day.